Alright. So 5.4 is called antiderivatives, or the verb of that is antidifferentiation, which is the same as finding the integral. Okay, so integral is the same as the antiderivative, so that is exactly what Alex did on the warm-up today. Okay, so we are going to start by just doing the basics, and we're going to start with deriving. Are you guys ready? I feel like we're not ready. Oh, we were waiting for Liz. I can check. I don't know off the top of my head. Alright, we ready? So what is the derivative of x cubed? Oh, good. Look at her just doing math as she sits down. Okay, what's the derivative of x cubed minus 10? Okay, so basically the whole point of this little first section, okay, is for you to understand that when you derive a function, it is possible to get the same derivative as something that was originally different, okay, based completely upon the constant value. Okay, so if you were going to derive question number 3, what would you say the derivative of that would be? 3x squared again. Okay, so it is important that you realize that there should be some constant that could have potentially been derived that we're going to label C by definition. Okay, so C is going to be our constant that we don't know. Okay, so what am I going to put in that little spot there for f of x? Okay, so it would be x cubed, so the antiderivative is x cubed plus c. Okay, so now you should see this new notation that might look familiar to you, maybe not. Okay, but this little curly S-y thing, stands for the integral. Okay, and then at the end of this, you guys see this dx. Okay, that is simply notation. Okay, you do not try to integrate that piece. It's like saying my original function was f of x. Okay, so in integral notation, they say, well, now I have a function that is in terms of x by labeling it at the end of the piece. Okay, so that dx is just notation. Okay, so what is the integral of 3x squared? X cubed plus c. Yep, exactly the same thing. So the antiderivative is the same as the integral. Okay, so we are going to be undoing the basic rule of differentiation. Okay, so we're just working on just basics. There are other rules that we will eventually learn for integration. We're going to do the basic today. Okay, so this is exactly what Alex came up with how to find integral. Okay, all you do is you add 1 to the exponent, and then you divide by that number. Okay, so for question number 4, what is the integral of x cubed? Okay, so we add 1 to the exponent and divide by it. Okay, so there's basically 2 different ways we could say this. We could say it's going to be x to the 4th over 4 plus c, or we can write it as 1/4 x to the 4th plus c. Okay, now I will probably go back and forth just depending on the problem between those 2 notations. Okay, sometimes one will be easier than the other, and we'll just have to play it by ear. Just realize those are exactly the same. Okay, what about question 5? What is the integral of 2? 2x plus c. Good. There's no other way to write that. Okay, question number 6. We just have now 2 terms on our function. So what is the integral of t to the 4th? T t to the 5th over 5, good. Okay, which by the way we could say is the same as 1/5 times t to the 5th. Okay, and if I integrate 2, what's the integral of 2? 2t, because we have a t this time, 2t. So notice that this notation becomes important because it tells us the variable. Okay, 2t, and then we always say plus c. Pretty easy? I'll take that as a yes. Okay, so let's make it a little bit more fun. Okay, question number 7. Okay, again, I'm going to integrate each term. Okay, so how would I do 2y squared? What's the integral of 2y squared? Okay, so you could say 2y cubed over 3, or you could say 2/3 y cubed. Either way. Okay, what about 4y? So 4y squared over 2, can we do that mentally and say that 4 over 2 is actually 2? So this would be 2y squared. Okay, what's the integral of 1? 1y or just y. And then what do I say last? Plus c. Okay. Here we go, number 8. Now number 8 is written as a fraction. So each of those two terms is written in a way that we can't instantly integrate. Okay, so the first thing that I want to do with question number 8 is rewrite it just like we did with the original functions when we differentiated. Okay, so how would I rewrite 3 over x squared? 3x to the negative 2. And how would I rewrite 1 over the square root of x? X to the negative 1/2. Now I can integrate this. This will be a little easier. Okay, so what is the integral of 3x to the negative 2? Remember, you're adding 1. What's that? N can be negative 1 because we'll simplify it afterwards when we're finished. So they want you to leave things simplified and not leave negative exponents. So you always want to rewrite it. Where was I? Okay, so we would say, did you guys say 3x to the negative 1 over negative 1? Which we would really say is negative 3 over x, right? Because the negative exponent moves into the denominator. Okay, what about for x to the negative 1/2? What's the integral of that? So if we add 1 to negative 1/2, we get positive 1/2. So you have to divide by 1/2. So how do you divide by a fraction? We can't leave it like that. Multiply by 2, right? So we multiply by the reciprocal. So the reciprocal of 1/2 is 2. So it's going to be times 2x to the 1/2 plus c. Everybody follow that one? Good? That one was a little more fun. Ready for 9? Okay, so 9, if this was given to us as a, go ahead and find the derivative question, we could rewrite it and do basic, or we could do the quotient rule. Okay, with integration, you need to rewrite it. Okay, especially as of now. So if I have something like this, this would be the same as x to the 1/2, right? Over x squared. Remember, if you have that denominator value, you put it underneath both pieces. Okay, actually I should write this as the integral dx if I wanted to be really good with my notation. Okay, now what do I do on that first term? If I have x to the 1/2 over x squared, what do I do with the exponents? Subtract them. So what's 1/2 minus 2? Okay, so I'm going to keep that as negative 3/2. And then how would I rewrite 1 over x squared? x to the negative 2, good, dx. Okay, so now, does that look like a 5 to you guys? Sorry, let me rewrite that. Kind of look like a 5 from far away. There we go. Okay, so now I can integrate this. Okay, so what's the integral of x to the negative 3 halves? Ooh, okay. Okay, so we would have x, yep, x to the negative 1/2 over negative 1/2, right? Everybody integrate that with just by adding 1. Okay, now how would I rewrite that? I can't have a fraction in the bottom and I can't have a negative exponent, so how would I write it? So what's the reciprocal of negative 1/2? 2, so I'm going to have negative 2 times negative 2 then goes basically up into the top, and my x has to go down into the bottom because it has a negative exponent. Good there? Okay, what's the integral of x to the negative 2? Good, so x to the negative 1 over negative 1, and how would I write that correctly? Basically flip them, yeah, so negative 1 over x. Okay, so I will tell you the hardest part of integration is fractions. So we good there? Okay, so we talked about the c part. They have that highlighted, so just don't forget plus c when you integrate. Okay, the next part of this is if they give you an initial condition, okay, we can actually figure out what the c value is. Okay, so for this problem, question 10, they give us this original information, which we can use at the end to find our c value. Okay, so I'm going to start by integrating because they give us the derivative. So what is the antiderivative of x to the negative 3? What's the antiderivative of x to the negative 3rd? X to the negative 2 over negative 2, right? Which then becomes, so we'd have a plus c. Okay, so how would I rewrite that? What happens with the 2? Does it get flipped upstairs? No, it stays in the bottom, right? Okay, because it doesn't have a negative exponent. It is not a fraction. Okay, notice before, like on question number 9, where we had the 1/2, that was flipped and why it went upstairs. Okay, the 2 stays in the bottom with the x. Okay, so this is going to be 1 over negative 2x squared plus c. Okay, so now if that's my integral, I can use that initial condition, the f of 1 is equal to 3 halves. What is the 1 and what is the 3 halves? The x and the y, okay? So my 3 halves is my y, so I would say 3 halves is equal to, and I'm going to plug the 1 into the x. And now I can solve for the c. Okay, so on that second little fraction, I have basically 1 squared times negative 2, which is negative 1/2. Okay, and if I just add the 1/2 to the other side, what's 3 halves plus 1/2? 2. Okay, so that basically gives me my c value. I can go back and rewrite my original function as 1 negative 1/2 x squared plus 2. How do I do on that one? Good? Not too bad? Okay, here's an interesting question. Okay, so this one says dx of the integral of that piece, dx. Okay, so if you look at question 11 and compare it to those ones up above, question 7, 8, and 9, what is different about that question? Yeah, there's a derivative thing, the d dx, that's in the front. Okay, and that's exactly what that means. Okay, so you guys should realize that this notion means to derive. Okay, it does. Okay, so if you derive an integral, they just cancel out, and you're left with just that function piece.
So what it says.
So what it says, yeah. So that would be equal to that. Okay. Okay, so a derivative cancels an integral. Unless you wanted to integrate it and then derive it. That would be kind of fun. It could be fun, especially on that one. It's pretty fun. Okay, so naturally they throw in acceleration, velocity, and position. I kind of said that in the wrong order. Exactly, because this is something that they ask you a lot of, especially in calculus. This just is like the bread and butter. Okay, so it is incredibly important for you guys to remember that if you have a position function, that the derivative of the position function gives you the velocity. And if you derive the velocity function, that gives you the acceleration. Okay, so if you go backwards, you would just integrate that to get back to your original. Okay, so that little highlighted piece is really super important. Okay, I imagine you probably have figured that out already. So maybe you don't need to write that down, but just know that it's very important. Okay, so for question 4, or 12, I mean, they give us the acceleration equation, and then they give us 2 additional pieces of information, which is going to allow us to come up with the c values. Okay, so they start with asking us for the velocity. So what am I going to do to find the velocity? Derive. Okay, so what, or not derive, integrate, right? That's what you meant to say, I'm sure. Okay, so it's the integral of 4t. Four t squared over 2. So 2t, good. I'm glad some of you guys said that. Okay, and then minus, what's the integral of 3? 3t. And then we'd have our constant. Okay, so that's our velocity. Okay, so since they gave us this information, the v of 1 is equal to 6, we can use that information to now solve for the c on our velocity function. Okay, so we're going to say that 6 is equal to 2 times 1 squared minus 3 times 1. Oops, I wrote a t, not a 1. Plus c. Okay, so that gives us 6 is equal to 2 minus 3 plus c. So does anybody else agree that c is equal to 7? Okay, so our velocity is 2t squared minus 3t plus 7. Okay, so now how do we go from the velocity function to the position function? Integrate it. Okay, so we're going to integrate the velocity. Okay, so what is the integral of 2t squared? Okay, so 2/3 t cubed minus, what's the integral of 3t? Good. 3/2 t to the second. The integral of 7. 7t, good. And then I have my second constant. Okay, so now I'm going to use the second piece of information. My position at 2 is 5. So I'm going to plug 5 is equal to 2/3 times 2. 3/2 times 2 squared plus 7 times 2 plus c. Oh, good. Okay, fractions. Okay, so we got 2 cubed is 8. 8 times 2 is 16, right? So we got 16 thirds minus, and then 2 squared is 4. 4 times 3 is 12. 12 divided by 2 is 6. 6 plus 14 plus C. Anybody find C? Faster than me? Nice. Negative 25 thirds. Perfect. So, our position function is 2 thirds t cubed minus 3 halves t squared plus 7t minus 25 thirds. Good there? All right, so here is the last piece of this. It's kind of interesting the way they do this. I'm not really a giant fan of the way they did this, but it's an important concept. Okay, so this last question is basically the idea of a free-falling object. Okay, so if I take my pen and I throw it into the air, this equation will hold true for any object that we throw into the air, or perhaps drop off of a cliff. Okay, so we know for a fact that things drop at a rate of negative 32 feet per second squared. Okay, so how do I put that into an equation? Okay, so what is the velocity of this going to be? So basically, they're giving us, what is this, by the way?
Gravity.
So is this a position? Is this a velocity? Is this an acceleration?
Acceleration.
It is an acceleration, and we can tell that by the units. Feet squared. I didn't say that right. Feet second squared. There it is. Okay, so they're basically telling us that the acceleration of any object is negative 32. Let's not add units there. Go back.
What's the?
There we go. The R. Where are you getting an R from? Oh yeah, I was trying to erase it. I was trying to write it feet, but I didn't want to write feet. Okay, so if I'm going to go to the velocity, what is the velocity of our acceleration for this? Negative 32 t. We good? Everybody good? I'm almost done. You guys are, I'm losing you. This is the last one. Okay, so on velocity of a falling object, the c value is your initial velocity. Okay, so they tell you that that is called v sub o. Okay, so that is a very important equation that you should remember always. Okay, they will not always give you this equation if they say, oh, we threw this thing into the air. Okay, so I would probably write this on every single notes card that I had for the next tests, all of them. Or memorize it, but that would be better. All right, so if I have my velocity, what's my position function? Good, negative 16 t squared. What's the integral of v sub o? Think of v sub o as some variable, or as some number, excuse me, as a constant. V sub o of t, good. And then plus some constant, initial constant. Okay, and again, they tell us what our initial constant value should be. Okay, the initial constant is the initial position. Okay, so highlight that somewhere in your notes. Well, that's all comes from the same piece. So either write down the position function, because you can always get to the other ones. Yep, that's a biggie. Okay, so that's it. Okay, so your guys' assignment is to finish this 5-4 assignment for me by Thursday. What day do I see you next? Thursday. Okay.